Hello, I'm Christopher and I'm going to show you many different things in this video. This video is going to show a variety of spacey things like how magnets have magnetic fields and how the telescope that's about to launch outside my house should maneuver through space to get to the edge of the solar system and back so that billions of dollars don't go to waste. Hold on! A telescope needs to account for fuel when going into space. Energy is very important for going to space, especially for a telescope because, you know, it runs a whole telescope part of the space telescope.
Duh.
Without that, it'd just be the space garbage, which isn't really useful for anything.
Wow, this is garbage.
The telescope will have to not use that much energy, get to the Earth and before all the power is drained, which would be pretty fast, and be close enough to the planets so that the telescope can observe, take pictures, etc. The perfect plan would be what I call the orbit hopper. So, the gravity of the planets create an orbit that causes objects in space to become attracted to it.
Hey, how you doing?
This plan consists of moving to a planet's orbit, staying in a perfect range of the planet to where the telescope doesn't crash into the planet, nor the telescope falls out of orbit, staying in that orbit until another planet gets relatively close, then using power to get out of that orbit and into the new planet's orbit.
This is going to be complicated.
This method would continue until we reach the edge of the solar system. Some sources that support what was said would be the FET gravity simulation,
The FET gravity simulation.
in which the Earth would crash into the sun or fall out of orbit depending on how much gravity was affecting Earth, and the String Live demonstration,
String live demonstration.
in which it demonstrated a perfect orbit around a celestial body because it was in a perfect range near the planet. Now, there are some people in this room that believe that magnetic fields don't exist. There are so many ways to prove them wrong.
What did you say about magnets?
Calm down. You need to have an open mind about things. Okay, so magnets contain certain properties that attract certain metals,
How you doing?
i.e. iron, cobalt, and nickel.
Iron, cobalt, and nickel.
Magnets have magnetic fields that pull objects in when it gets close enough to the magnet. When a paperclip gets close enough to a magnet, the magnet pulls in the paperclip through the magnetic field that is owned by that magnet. Any normal electrical conductor can become magnetic if the item gets an electrical charge. When a nail gets an electrical charge from a battery, it can attract a group of paperclips. If you place a magnet near a bag full of iron fillings, you can even spot the exact magnetic field that surrounds the magnet. Do you believe me now?
Whoa! I had no ideas magnets could be this cool.
Okay, no. A telescope needs a lot of protection when going into space. There are many different hazards in space that a telescope should be worried about. The freezing temperature, solar wind, objects in space. I'm here to explain methods of protection against each of those problems. Freezing temperatures would make technology not able to function as quickly or just not work at all. Thermal blankets should be a good method to combat this. Thermal blankets would warm up the systems, causing them to function as normal. Solar winds are very fatal to this mission. The telescope, if touched by the solar wind, can overheat the mechanisms, or the magnetic field that the wind bottles can cause the telescope to act funky and weird. Electromagnets can repel the solar wind if it is placed around the telescope. The electromagnet would have to be huge and contain a type of metal which conducts electricity. A nail would have to be huge and contain a conductor to create the biggest magnetic field. The last problem is random objects flying through space that could collide with the telescope. The telescope could get severely damaged from objects running into it at very fast speeds. Thick layers of metal act as a shield against those collisions. I hope that telescope used these methods. It's fine, I hope. Jupiter's magnetic field is probably some of the strongest magnetic forces in the entire solar system. So this is a drawing of Jupiter's magnetic force. It's extremely huge and is probably some of the strongest in the entire universe. And if the telescope gets near it, then a lot of really strange things can happen. Instruments use magnets or magnetism to function, so Jupiter can mess them up by interrupting the force, causing the instruments to act strangely or just not work at all. The telescope has a lot of magnetic metals inside of it, so if it were to come in contact with Jupiter's magnetic force, then it could just get attracted to it until eventually it would just fall onto Jupiter's surface and possibly like break or just completely destroy itself. Some sources to support this would be the Task 4 Station 2, where if we took a magnet and we took a paper clip and we put them close together, then the paperclip would become attracted to the magnet since it has a magnetic metal inside of it, and so it would just come in contact. So, what's the point of sending telescopes into space? Well, once you get past the atmosphere, which blurs the images, you get pictures like this. And this. I mean, this too. And this. And this. I really think you get the point by now. Thank you so much for watching this video. Today we found out the best way to navigate through a solar system, explained to a non-believer that there is a such thing as magnetic fields, talked about ways that a space telescope can protect itself against hazards in space, and talked about Jupiter and its magnetic field. We've accomplished a lot of things, so thanks for tagging along.
Happy trails to till we meet again.